Today we'll understand the concept of the flow of electron inside a conductor. Concept of flow of current inside a conductor. So we know the current is the rate of flow of electron inside a conductor when we apply a potential difference across it. But how the electrons flows inside the conductor, that we want to understand. So to understand this, we have to understand the concept of drift velocity. So we can consider a conductor consisting of electrons which are moving randomly inside the conductor like a gas molecules, and the energy the electron is getting from the heat or the room temperature or thermal energy. So due to the thermal energy, the electrons move randomly inside a conductor. Normal conductor means when no potential difference is across it, and they move in such a way that average velocities of all the electrons is 0. But what happens if we apply a potential difference across a conductor? So when we apply a potential difference across it, apart from the random motion of the electrons will drift towards the positive end of the conductor, and this velocity with which the electrons on average will drift towards the positive end of the conductor is called the drift velocity. So now we'll derive an expression for drift velocity. So let us consider a conductor, and let us consider there are n number of electrons inside the conductor and they are moving randomly, and we are applying a voltage, a battery across this conductor. So current will starts to flow, electron will starts to flow from the negative end to positive end, and the drift velocity is the average velocity with which the electrons will be drifted towards the positive end of the conductor when we apply the potential difference across it. So when we apply a potential difference across it, an electric field is developed across the conductor. The electric field is directed from positive end to negative end, and we know that when we place a charged particle inside an electric field, it will experiences a force, and that force is given by Q into E. So here force is given by minus E into electric field. E is the charge of an electron and E is the electric field. So now due to the force, all the electrons will be accelerated in this direction, and acceleration is given by E by m, where E is the electric field, capital E, and m is the mass of the electrons. And since before application of the voltage, electrons are moving randomly, they are having an initial velocity. So let us consider initial velocities of the first electron be u1. On application of the potential difference, the electrons will be accelerated, so final velocity will be v1 is equal to u1 plus a tau 1, and tau 1 is the time. This time is called relaxation time, means time the electron will move before colliding with another molecules, and this time are not constant for all the electrons. So we take all the time is different for all the electrons. So for second electron, let initial velocities be u2, so final velocity will be v2 is equal to u2 plus a tau 2, and tau 2 the relaxation time for the second electron. Similarly for nth electron, vn is equal to un plus a tau n. So all relaxation times will be different because they are unpredictable, how much time they will move before collisions. So if we average all the final velocities of all the electrons, will get the drift velocity. So drift velocity is v1 plus v2 plus dot 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 vn by all divided by n. Now if we put the values of v1, v2, v3, vn from this, we'll get the expression like this. and if we separate u1 terms, u terms, we'll get u1 dash plus u2 dash plus u3 dash dot 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 un divided by n, u1 plus u2 plus u3 plus un by n, and a tau 1 plus tau 2 plus tau 3 dot 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 tau n by n. So this term is called average relaxation time. Average of all relaxation time is called average relaxation time. And this term will be 0 because average velocities of all the electrons before application of the battery is 0. So initial velocities will be 0. So drift velocity becomes a into tau average. A is the acceleration. If you put the value of acceleration, it becomes E by m into tau average. So from this expression, it is clear that drift velocity depends on the electric field and the average velocity. If we increase the electric field, drift velocity will increase. Now this average relaxation time will depend on the temperature of the conductor. If we increase the temperature, the electrons will move randomly, so relaxation time will reduce, and the average relaxation time also reduce. So drift velocity will also reduce. So as we increase the temperature, drift velocity will reduce. So this is the concept of drift velocity, and this is the expression Vd is equal to E by m into tau average.